We're looking at here at some graphs of parabolas of quadratic functions, and we want to be able to state a variety of properties of them listed below each one. So we'll start off with the first one. I'm not given the equation of this parabola here. I'm just given the graph of it. Now the domain of any parabola is always going to be all real numbers. So I can rewrite in here, my domain is x belongs to the set of real numbers. For my range, that's all the y values, and if you look at your graph, all you have to determine is, well, what's the lowest point? If I look closely here, I see that my lowest point is going to be -2. Everything on this graph lies above -2. So my y values are everything above -2, and there should be arrows on the end here. So for my range, I'm going to write y is an element of the real numbers such that y is greater than or equal to -2. Now that value there happens to be a minimum value, and the minimum value is -2, it's the smallest. The axis of symmetry is the line that goes through the middle of this parabola. So if I were to, again, zoom in here and draw a vertical line right down the middle, it goes through 4. So my axis of symmetry is going to be x equals 4. My zeros, well, that's where the parabola intersects the x-axis. So if I zoom in again and I look here, it happens at 6 and it happens at 2. So my zeros are, I'm not going to write it like that, at 2 and 6. Alternatively, you can also write it as 2, 0 and 6, 0. Either one is acceptable. Finally, my vertex is the coordinates of that lowest point, which is right here. That ends up being actually the axis of symmetry value and the minimum value. So in this case, my vertex will be 4, -2. So here I'm going to go 4 and -2. If you observe, these two guys here are what make up your vertex in here. Just a little observation to take note. For the second one, here is my graph. My domain, like I said, is always going to be the same. So I'm always going to have all real numbers. So x belongs to the set of real numbers. My range, let me just start writing it off. It'll be y belongs to the set of real numbers such that, let's look closely here, the highest value is right here at 8. Every single y value is going to be below that number 8. So in this case, the range is everything less than or equal to 8. So I can write in over here, y is less than or equal to 8. And this happens to be a maximum, which is going to be a value of 8. The axis of symmetry, again looking closely at our line, we see that it goes through this point here, so that's -1. So I can write x equals -1. My zeros, look closely again, I have one here at 1, one here at -3. So I'll write my zeros in coordinate form. So I have -3, 0, and I have 1, 0. And finally the vertex, which again by looking at the graph you can see it's up here at the coordinates of 1, 8, or you can just read them off these 2 points here. Either way will lead you to the same answer. So -1, 8. So those are our first two graphs listing some properties of quadratic functions of the parabolas there. Now let's move on to the next two, which are slightly different. Domain, same thing. All real numbers. Now the range for this one, if I look closely, the lowest value of this graph is a value of 1. So this graph is everything above a value of 1. So I write that in. Y belongs to the set of real numbers such that y is greater than or equal to 1. And this is a minimum of 1. My axis of symmetry, again looking closely, looks like it goes through 3. So 3 is my axis of symmetry, so I'm going to write x equals 3. My zeros, well, do I have any? Indeed, no, I don't. If you look at the graph, at no point does it intersect over here on the x-axis. So the zeros are actually none. And finally, my vertex, I'll just read it off my axis of symmetry, and my minimum is 3, 1. So to save myself some time, I already know for the next one, my domain is going to be this guy here. Now my range, looking out at the graph, my highest value in this case is 0. So y is everything below 0, or y is everything less than or equal to 0. So y belongs to the set of real numbers. Y is less than or equal to 0. And this is a maximum point, and the maximum value is 0. The axis of symmetry is what goes right down through here, which is -3. So we have x equals -3. And finally the zeros, well, we only have 1, and that is the vertex itself. Oh, made a mistake here. -3, 0. And the vertex is actually the same thing. So I'm just going to copy this, paste it here, and there you go. So these are all 4 functions with some properties about their graphs listed for you.